All right, lesson 2. The topic today is I want you to be able to, we're converting between metric and imperial. So the goal today, I want you to be able to take a metric and an imperial measurement and go back and forth. And you're going to use ratio and proportion. It's very, very similar to the strategy I taught you in lesson number 1. So I'm not going to beat around the bush. We're going straight to examples. So I want to go from 17 inches to centimeters. So it's the same setup, x centimeters over 17 inches. You're going to need your conversion chart from yesterday. Okay, so I've got it on another file here. So I want to go centimeters to inches. So if I'm looking for centimeters and inches, I'm looking for measurement. So where are you? Here's inches, and here's centimeters. Okay, so we can use that one. If you find another one that's a little bit better to use, you can. So 36 inches is the same as 91 centimeters. So 91 centimeters, 36 inches. Okay, again, the only reason we do the units is to make sure they line up. All right, so you want centimeters together, you want inches together. Now you're just solving for x, and we can drop off the units. So partial cross multiply, that's why we have that variable on top. So we'll have the 17 times 91 divided by 36 to get our final answer. And it comes out to be pretty much 43, let's call it. So 43 centimeters. So we're giving it's an approximation. We can do the decimals. It depends on the context here, but 17 inches is approximately 43 centimeters. It's 42.97. So 43 centimeters. Now, if we want to go meters to feet, and you're starting to see the pattern here. So 34 meters to feet. So I don't know the amount of feet. Over 34 meters will equal. We go to our chart from the other day, and we're looking for meters and feet. I know 3 feet. There's 0.91 meters, so I can use that one. So I know that 3 feet is 0.91 meters. Again, the units are only used to make sure they line everything up. Partial cross multiply, same as we do with similar triangles. So we get 34 times 3, and that's divided by 0.91. And that gives us a final answer of 112. What were we looking for? 112 feet. Okay? So it's the same process over and over again. I'll do one more, and then the fourth one's a little bit different. So pounds to kilograms. So how many kilograms are in 125 pounds? I don't need to look at my conversion sheet because I know that for every 1 kilogram, there's 2.2 pounds. And just something from over time that I just remember. So partial multiply up, and we have that x is equal to 125 times 1 divided by 2.2. So now you go ahead and you do your calculations, and you get 56.8. So 56.8 kilograms. So 125 pounds is about 56.8. Now temperature is a little bit different. So if you have a friend up from the US and you want to explain how hot it is because they'll be accustomed to Fahrenheit, the rule, so if we are going from degrees to Fahrenheit, the rule, double and add 30. So I'm not going to give you the formula to do the calculation, okay? I'm just going to give you the approximation because you're never going to have to calculate the exact. You can always Google that. But I want you to be able to look at it and say, oh, I know what that is. So you just double degrees and you add 30. So for ours, 22 degrees Celsius is approximately equal to, if I double 22, I get 44, add 30. So that's about 74 degrees Fahrenheit. Okay? Just as a follow-up, if I want to go Fahrenheit to degrees, all right, the rule is the opposite. So we would subtract 30 and half So I'll just make up a quick example here. So what happens if we have, and we'll pick an easy number here, 100 degrees Fahrenheit. So if you call down, talking to your grandma or grandpa who's in Florida, and they say, oh, it's 100 degrees Fahrenheit, in your head, you would say, okay, 100 degrees Fahrenheit is equal to, I want to take away 30, so 100. I'm going to take away 30 and then divide that by 2. So that's 100 divided by, or minus 30 is 70. And I'm going to half that. 70 divided by 2. It's 35 degrees Celsius. It's like, holy cow, that is hot. All right. So those are the rules. Rule of thumb. Probably something you're going to use quite often, to be quite honest, because it's not uncommon. A lot of people do measure in Fahrenheit, and if you're watching TV, okay, we got a lot of American channels now, so you do see quite a bit of stuff reported in Fahrenheit. So good skill to have, and good thing to remember. And it gives you an approximation. It's not exact, but when does it matter to be that exact in terms of temperature unless you're in a science lab? Okay, 2 final examples here. So your cousins in the U.S. are visiting. To help with cost conversion, explain to them how much does $1.30 per liter of gasoline is in terms of American money in gallons. Okay, so what we're going to do, we're going to make life a little bit easier because the focus isn't converting money. So a while ago, the Canadian and the American dollar was the same. So we're going to assume that $1 Canadian is equal to $1 American, even though presently you never know where it is. So just to make this example a little bit easier. So $1.30 per liter, and we want to convert it to X dollars per gallon. All right, which means that we got to convert 1 liter to a gallon. All right, so therefore 1 liter is equal to, I'm just going to introduce a different variable because I don't want to use X again, Y gallons. All right, so going over here, that means that Y gallon over 1 liter is equal to, so you get your conversion chart out, and we're looking for liters and gallons, so volumes. So there's gallons, there's liters, so 1 gallon has 3.8 liters. So 1 gallon has 3.8 liters. Do the cross multiply, but it's a 1, so it's really not going to change anything. So we end up with Y gallons is equal to 1 divided by 3.8. You don't have to have that gallons there, right? Because I said we can drop the unit notation here. Now we don't want it as a fraction. We're going to convert that to a decimal. And it comes out to be about and we'll call it 0.3 gallons. So what does that mean? Well, I know that now my unit rate is going to change. So I'm just going to shrink this to make a little bit more room. So to finish this off, I missed some of the stuff. Oh, forget about that. To finish this off then, just come over here. So therefore, $1.30 per liter is equal to $1.30 per 0.3 gallons. Okay, so $1.30 per liter is equal to $1.30 per 0.3 gallons. So what we're going to do is we're actually going to do that division, $1.30, because as a ratio we want it as 1. So we're actually going to do the 1.3 divided by 0.3, which gives us 4.33 per, and I'm going to exaggerate, I'll put the 1 in there, per 1 gallon. So if in Canada, so therefore, $1.30 per liter is the same as 4.33 a gallon in the U.S. So if they're comparing with what the price was wherever they're coming from, Florida, or if they're coming from Alabama or Georgia, you can say, well, we're paying $1.30 per liter. It's about 4.33 a gallon, and they'll look at you crazy because their gas prices are actually a lot lower than ours, due to a combination of things, competition, taxes, etc. So, Usually, last time I was in the States, and that might change, gas was going for about $3, 3.60 a gallon, somewhere in there. So, okay, many European farm equipment. So we have a lot of European farm equipment coming in. They use metric wrenches. So although it's not exact, I know you're going to be saying, wait a minute, it doesn't work this way. I know, but what's the approximate metric size bolts that work with a 9/16 and 3/4 inch wrench? Okay, so I just want to convert your 9/16 wrench that's in your toolbox. I want to convert it to, and they're in millimeters, those wrenches. So doing the conversion, I want to know how many millimeters are in 9/16 of an inch. So I'm going to have to go millimeters to inches. So you need to get that sheet out again. We got to find millimeters and inches. So where are we? Where can we get millimeters and inches? So I'm going to have to come here. So I know I have 36 inches and 91 centimeters, but I know 91 centimeters is 910 millimeters, right? Just using, we know from the metric system. So 36 inches has 910 millimeters. So, oops, wrong button, sorry. So I know that there are 910 millimeters for every 36 inches. Okay, so doing the cross or the multiply here, 9/16, you got to convert that to some form of decimal for yourself, and we'll calculate that out. And that comes out to be 14.2 millimeters. All right. Now, in all honesty, if you look in the tool set, I don't know how many of you have actually used the metric tool set before. There's no 14.2 millimeter wrench. I believe there's a 15 millimeter wrench. So therefore, need to use the 15 millimeter wrench. It'll be close. It'll be sloppy. It'll round your bolt or your nut a little bit if it slips. But so I'm just going to do the one conversion because by now you see what the pattern is. So I'm just going to cross that out. All right. So you don't have to memorize. For people who are worried about having to memorize what metric wrenches exist in the world, don't worry about it. I'm just looking for an equivalent. So you're looking for about a 14 millimeter wrench in order to work. For the people that have used both sets of wrenches, you know it can be a little bit frustrating when you're flipping back and forth in the shop. You got to be neat and tidy about it. So if you have any questions with the process, let me know in class and we will solve all the problems hopefully. Good luck.